Again, welcome back to Pre-Calculus. This lectures cover the radicals and rational exponents. This is Unit 1, lecture number 4. So example 1, roots. Here they say we should find the roots if they are real numbers. So our first question is 64 root 6. So let's look at the solution. But we know 64 is the same as 2 to the power 6. And root 6 means the power is 1/6. So we can convert 64 to 2 to the power 6, then everything to the power 1/6 because root 6 is 1/6. Now we know the multiplication rule for the exponent. Anything raised to, for example, we have 2 to the power 6 to the power 1/6. It means we are going to multiply 6 by 1/6. Now 6 by 1/6 will give me 1. So the final solution will be 2 or 2 to the power 1. Again, the root always is reciprocal. So if I have 2 here, or let's say square root of 64, it's the same as saying 64 to the power half, 1/2. So 64 root 6 is the same as saying 64 to the power 1/6. Then we know 64 is the same as saying 2 to the power 6. So we are going to get 2 to the power 6 to the power 1/6. Which means we are going to multiply 6 by 1/6, which will give us 1. So the answer is 2. Now, second question, we have now here we can see that the negative sign is outside the square root. We know that in radicals, if the root is even number and the value is negative, then we cannot get a real answer. There's no solution. But if the root is odd number, whether the value is positive or negative, we are going to get the answer. So here we're going to get an answer because the negative doesn't affect the root sign or the radical. So 16 is the same as saying 4 to the power 2. And as we said, the radical sign square means anything to the power half. So this means 16 will be 4 to the power 2 times half. So our final solution again will be 4. Now, since we have negative in front of the expression, we put a negative 4. So next is the negative 8. This time is odd number cube. So this, we can solve it. So again, if the 3 is even number, there's no solution. So here we get negative 8 cube root. We know that 8 is the same as 2 to the power 3. So this means we can convert negative 8 root 3 to negative 2 to the power 1/3. Since we know, again, 2 means 8, it will be 2 to the power 3, then to the power again 1/3. The power 1/3 is the root, and 2 to the power 3 is the same as 8. So this means, again, the power 1/3 and 3 will cancel, and the final answer will be negative 2. Next question, we have a square root. So square root is an even number, and we have a negative value, so this is not a real number. Again, if the root is even number, the values must be positive inside the root. So here we have stated that if A is greater than or equal to 0, and B is greater than or equal to 0, then we can say that the square root of A is equal to B only if A equal to B squared. So if we have a square, when you cross the equal sign, it becomes square root. When we have a square root, when you cross the equal sign, it becomes square. So it's the same. If this square cross the equal sign, then it will be root A equal to B. And that's what we have here. Also, if we have root A or square root of A to the power 2, as we said earlier, again, square root of A means the power is half. So it will be half A to the power half multiply by 2, which will give us a. And that's what we have here. So a to the power half is the same as square root of a. So if I have a to the power half, which is square root of a, to the power 2, the half times 2 will give me 1. So the answer will be a. Now let's see some few examples here. Our first question said, we should simplify the following. We have a to the power half times a to the power 1/6. Again, here we use the multiplication rule. The base are the same. So we are going to add the exponents. So we get half plus 1/6. And that will give us a 3/6 plus 1/6. We make the common denominator 6. So our final answer will be 4/6. And for 6, we can reduce it to 2/3. The only thing we should know here is that, again, the rule of exponents. The base a, they are the same, and they are multiplying. So this means we have to keep a, only one a, and we had the 2 exponents. Now, if they are dividing, then we have to subtract the denominator exponent from the numerator exponent. So let's try second example. That's what we have here. A 3/4 divided by a 1/3. Now, this is division. So it means we are going to subtract the denominator exponent from the numerator exponent. Again, we only do this if the base are the same. So here we have base A, base A. So we write down the base A, then we have 3/4 minus 1/3. And that will give us, we find the common denominator. So we get 9/12 minus 4/12. And that will give us again 5/12. Next question, we have a cube b to the power 2/3. So what we can do, we can separate a cube b. So we can say a cube b multiplied by 2/3, then b multiplied by 2/3. And they have to be exponents. So that's what we have here. A to the power 3, everything raised to the power 2/3. Then b is by itself, so it's raised to the power 2/3. So this means our final answer, we can see 3 to 10, the 3 will cancel each other, so it will remain 2. B is by itself 2/3, so the answer will be B 2/3. Okay, one more example, a to the power 3 by 2 to the power half. So this means we have to multiply the exponents. So we have 3 by 2 times 1/2. And that will give us 3 by 4. 3 times 1 is 3, 4 times 2 is 4. So here we also have a to the power -half times a to the power -3, 2. Now the base is the same, a and a, so we need to add the exponent. So here we have a to the power -half plus -3 by 2. But positive and negative, we change it to negative. So that's why we have -half, -3, 2. Because if I have negative and positive, the answer will be, again, if we have positive times negative, the answer will be negative. So we get our final answer will be a to the power -2, which is the same as 1 over a squared, the reciprocal of it. So now we can perform operations with radicals by first rewriting in exponential form. Then we perform the operations with exponents. Then we convert the answer back to radical form. Another option, again, is to apply directly the following rules for operations with radicals. So they give us a root n and also b root n. And these are real numbers. So it's the same as saying 1, we have a to the power n root n. So the n and n will cancel because we know root n is 1 over n. So we get a to the power n times 1 over n, and that will give me a. Next, we have a root n times b root n. So we can add the two. So we get ab to the power root n because a, the root is n, b, also the root is n. So both of them have the same root. Now, if the root is different, then we can't do this. We cannot. Now, with division, we have a to the power root n divided by b to the power root n. We can combine all that root n to the power a by b. So now let us consider rule 1 for radicals more carefully. We should know that if n is even and also a is less than 4, then a root n is not real. What we mean is that, less than 0. What we mean is that if a is a negative value and the root is even number, then we don't have a solution. But if the root is a odd number and a is a negative value, we still get a solution. So that's what it's saying here. We have a square root of negative 2 to the power 2. There's no solution. Or square root of 2 square or radical. There's a solution here because why? We can see the negative 2 is in parentheses, so this square affects again the sign also. So negative square, which is negative times negative, is positive. So there's a solution here. That's why we get square root of 4, and the answer is 2. Also, we can generalize this observation as following. If a is less than 0, then the square root of a squared is equal to negative a should be greater than 0. So that again, a square root equal to a if only a is greater than or equal to 0, and also equal to negative a if a is less than 0. Now we can use the rules for radicals to simplify radical expression. Also in general, a radical expression is considered simplified if x has no nth powers as factors. So this is our root 2 here. If I have the same root n and a and b, they are multiplying. So I can multiply a and b and I'll keep one of the n. So let's see some example here. They say we should do some multiplication here. We have 2xy to the power cube root or 2xy cube root or to the power 1/3 times 4x squared y cube root or to the power 1/3. So this means we can, 2xy is like we have 3 different terms. So since both of them are cube, we can combine both. So you can see here we combine 2xy and 4x squared y. Then we can give the cube root to each term. Or first we can multiply 2 by 4, x by x squared give me x cubed, then y by y is y squared. Then again, from there we can solve the problem. So that's what we did here. 4 times 2 is 8. X times x squared give me x cubed. Y times y will give me y squared. And that would be the solution. So our solution will be 2x, y squared, cube root. So another example, we have 8x y cubed z times square root of 4x squared y cubed z squared. Again, combine the whole term. The like terms combine. 8 times 4 is 32. X times x squared will give me x cubed because it will be 1 plus 2. The base is the same, x. Then y times y cubed. This y here is again y cubed times y cubed. So that will give me y6. Then z times z squared will give me z cubed. So here we can again separate it. 16 by 2 will give us 16. 32 by 2 will give us 16. So that's why we have the 16 here. We break the 32 out. And the same thing, s cubed is the same as saying s squared and x. Then y6, we can keep all the y6 because square is half, so it will cancel. Then z cubed and z squared. So here also we can get reduce the z. So let's see, the first thing they did here is that they separate these two terms because the one in front of us, 16, s squared, y6, z squared, square root can go inside. So that's the main goal of doing this. So 16 will give us 4 because 4 squared is 16. S squared will give us s because x squared is s squared by itself will give us s squared also. Then we have y6 will tend to y cubed. Z squared will be 1, so it will be z. And then we write our answer here. 4x y cubed z, then square root of 2xz. Now, next, they say we should express the following with radicals in the denominator. Now, when they say radicals in the denominator, it's concept of rationalizing each denominator. So our goal again is to remove the denominator. So here we wish to create a perfect square under the radical in the denominator. So we came up with the square root of x divided by square root of x. So here we can solve this problem. 15 times square root of x will give me 15 square root of x. Now, square root of x times square root of x will be x because the exponent of square is half. So s to the power half plus half, that will give me 1. So that's why here we have the x, or square root of s squared, and the 2's will cancel. The exponent will be half times 2, so they will cancel. Next example, we have 2x, square root of 18xy. So first, we multiply and divide by 2xy. Then from here, we can combine. So we have 2x, square root of 2sy, then 36x squared y squared. So that will give us 2x, square root of 2sy, 36, square root of 36 is 6. S squared is x, y squared is y. So the final answer will be 2sy divided by 3y because the x here cancel the x down. Now we wish to create a perfect cube under the radical in the denominator. So we have this question here. Again, here, the goal is to remove the radical sign at the denominator. That's what we did here. So if I have a question like this, we need to look at it first. First is cube root. So let's combine. 2 times 4 is 8. S squared times s is s cubed. And here our goal again is to remove the radical. So we know 2 to the power 3 is 8 and s cubed. So that will be the conclusion for these lectures. And again, thank you for your time and see you in the next lectures.